Today, it's my honor to welcome Professor Paul Simons to talk about how SLAM is being used in RoboCup. He's the president-elect of RoboCup.
We ran RoboCup last month, and it was an unusual RoboCup because normally we would be doing this live with real robots, but a lot of it was done online. But I'm going to be talking mostly about our rescue competition because that's the one that relies very heavily on SLAM, which is today's theme. But just in general, RoboCup is an international competition that started in 1997, and its intention is to use the competition to encourage research in advances in AI and robotics. And it's open to universities and research labs from all over the world. And there's also a junior competition for encouraging school students to get into these sort of subjects. Now, initially, RoboCup started with a soccer competition, and currently there are several different leagues of soccer, but in the top left you see an illustration of the standard platform league where we all use the same kind of robot. And over time, new leagues were added, including industrial and at home for domestic robots and rescue competition. And as I said, I'll be focusing mostly on the rescue competition because in the case of mobile robots working in unstructured environments, they obviously have to know where they are relative to everything in their environment. And that means mapping the environment and localizing the robot within the environment. So it's simultaneous localization and mapping, SLAM.
Pickerbot. What is Pickerbot? So since COVID-19, there are a lot of countries are facing a same problem, labor shortage. Why is that? Because the international borders are closed. So there are a lot of countries like Australia, New Zealand, Great Britain, and even China. We don't have enough people to pick the fruits. So they are simply just rotten in the field. So how do we solve this problem? We created Pickerbot. So it's a very small robot, but it's smart enough to pick anything from anywhere. Not only just the fruits, it also picks big data. It will help the farmer to improve their yield prediction. And it also helps the farmer to manage the field. And it's very efficient to transport anything like tomatoes and fruits from the greenhouse to the warehouse. I'd like to show you a video of how Pickerbot works in the greenhouse. Okay.
Angin bawa kabar ke sana. Bangsa di sini so rindu pada biar kopi jauh di sana. Tak ada yang mau ganti. Kevin Rather on the mix. Angin bawa kabar ke sana, bilang pasapu sayang. Bangsa di sini so rindu pada biar kopi jauh di sana, saya juga jauh di sini. Tak ada yang mau ganti. Kopung posisi. Kevin Rather on the mix. Kopung posisi. Kopung posisi. Kopung posisi. Sudah Joko mau ragu-ragu, dah tunggu Jo di situ. Satara baku seduh, hingga itu. Tahan rindu dulu, tunggu sabar ke situ. Nanti saya kasih tunjuk kalau saya serius. Pasapu hati cuma satu, hanya goyang diam di situ.
Okay, so what you saw, the greenhouse is the largest one in Asia. So in fact, my colleague Sky is actually now standing in that greenhouse, the largest one in Asia. So Sky, are you there?
So, hello everyone, my name is Sky. I'm currently standing at the largest tomato greenhouse in Asia. I mean, it is as big as 50 football courts here.
And you can control everything. You can control the heat. You can control how much light goes into the system and the amount of water goes into each plant. And all of these are activated and adjusted by computer, which makes things pretty efficient.
So, as you can see from the top here, we have the depth camera here. So with that combined with our deep learning technology, our Pickerbot can easily recognize which tomato is ripe and which one is ready to pick. And also, along with the arms, we are coming to the central processing system here. So this is more like a brain of the Pickerbot. It controls everything, like when to move, when we need to charge, and when to pick. That's pretty remarkable. If we come to the bottom here, so we have enhanced four-wheel drive for Pickerbot as well. So it allows Pickerbot to go almost everywhere it wants.
Anyone, my name is Andy Jun. I'm working at Yujin Robot AMS business unit and head of the component sales. So today's agenda will cover Yujin's autonomous mobility solution and the Yujin LiDAR and our SLAM solution. At the end, I will explain some of the case study material. So some of the customer or audience know about our company Yujin Robot, but I can speak a little bit more details about our company. And we established in 1988, and our company is listed in Kosdaq market in Korea. Total 160 people is working, and 60% of the employees working for R&D sectors. So we are based in Korea, nearby Incheon. So starting from our factory automation business in 1988, we've been developed different type of the robot, including soccer robot and social robot. And we also strong the manufacturing company of the robot vacuum cleaners. So we call iClever brand. At the same time, we are still village ODM, the provider for Scout for the robot vacuum cleaners, brand name of the village. And 2011, we launched for a mobile platform, so we call Gobuki for open source the platform basis. And also in 2016, we launched for a logistic robot, so we call Go-Kart. And last year, we recently launched for LiDAR sensors using LiDAR. So 100% is made by Yujin Robot here in Korea. And in summary, Yujin Robot has the more than 30 years of experience in the field of the robotics.
There is one more thing. So these are the oil tanks. So each of these oil tanks is about 20 to 30,000 square meters. And each year, the oil company have to apply, hire about 20 people to clean the surface of the oil tank. It takes about 10 days to do that for 20 people. And besides, it's a very hazardous environment. So we are tasked to solve this problem by creating this robot called Zorro. So Zorro is the best friend of Ironman because it scratches and also cleans the metal surface. How good is Zorro? So firstly, Zorro grinds and moves at the same goal. So it means Zorro is grinding on the rusty surface, sucks the rust, and also moves at the same time. So it really means Zorro has to be very powerful and also efficient at the same time. So once it collects the rust into the container, so you can replace the container very, very easily. And same for the battery. So if the battery is running out, you can replace the battery very quickly. And it's very smart and smart enough to avoid any obstacles on its way. So this is a very challenging project. Okay, why? From design perspective, Zorro has to go through a very small entry of the oil tank. So that means we have to design Zorro in a very compact design format. And yet it need to be also powerful to clean the surface of the oil tank. Okay, so that's challenge number one. Challenge number two, when we test the product, we have to go into the oil tank. As I mentioned, it's a hazardous environment, so it's not very easy. So today I'd like to show you behind the scene video. Just you see how tough the situation is. So let me play the video. Today, we have Professor Klaus Simon to talk about how SLAM is used in RoboCup. We have Mr. Andy Jun from Yujin Robot to present to you the latest LiDAR and SLAM solutions. And we just announced 2 robots, Pickerbot and Zorro. That's not it. That's not it. I have one more video to show you. Okay, thank you everyone, and especially thank you for Professor Klaus Simon and also Mr. Andy Jun from Yujin Robot. And thank you also for Universal Robots. And also please allow me to give a big round of applause to our colleagues who have been working very hard for RoboShow. So thank you, my dear colleagues. And thank you, that's all. And I look forward to seeing you next year. Thank you.